We have a speed time graph here, and then we're asked to find the distance. Now actually, there's a formula speed equals distance over time, but that only works when you're going at a constant speed. You could use it on this bit here, but you couldn't use it on this first bit. Actually, the best way to do this question is to realize that it's actually the area under the graph that you're trying to find. That gives you the distance. So we can split it into a rectangle and a triangle. Now the rectangle is going from 15 to 40, so it has width of 25 and it has a height of 30. And meanwhile the triangle has a width of 15 and also a height of 30. So we can do a half times 30 times 15 plus 25 times 30. Alrighty, 975 meters. Moving on, we've got a slightly more complicated distance time graph now because it's not a straight line, it's a curve. Work out the average speed of the particle between 2 and 4 seconds. Okay, it's important here to realize that the speed is changing as we go on up, as the speed is actually the gradient essentially, but the average speed is going to be, we can use the distance after 2 seconds, and we can use the distance after 4 seconds and draw a straight line like so. This has, so 2 seconds is the time difference, and then we need to read carefully off this graph. So this looks like 6, and then up here 24, so it's going to be 18 in height, and then the average speed is going to be the distance over time, 18 over 2, 9 meters per second. Estimate the speed of the particle at 4 seconds. So what does that mean? So we can do the average speed by this line, but when we're estimating, we can see that it's changing. What we have to do here is actually draw a tangent. So I'm just going to get rid of this to make things a bit clearer. Okay, so we need to draw a tangent onto the graph at this point here. This might take a few little attempts. I'm going to make the line really thin. Okay, it's easier when you've got a ruler. That's not bad. There'll be like a range of values that are accepted here. It's just got to just touch at that point. And I'm going to make it the triangle as big as possible so that my reading will be more accurate. So I'm quite happy with that. Okay, now that's quite good. It's actually hit pretty much at 2, so I can use that the width is 4, and because I've made it all the way down to 0, I just need to read off this value up here, and that is about 48. So to estimate the speed, it's going to be approximately 48 over 4, which is 12 meters per second. So what we're doing essentially is finding the instantaneous gradient. This is drawing the tangent gives you that. You draw the tangent like carefully so it just touches. Make the triangle big so there's less error involved. In this case, it's worked out nicely at 12, but a range of values would be accepted, like I said.